We have till now studied about addition and oxidation of alkenes. The next reaction of alkenes is ozonolysis. We all know what is ozone. Ozone is O3, that is 3 atoms of oxygen form an ozone molecule. Ozone is important because ozone constitutes of a thin layer of the atmosphere which protects us from the UV radiations of the sun. So, when we react alkenes with ozone, we form products and this reaction is called ozonolysis. So, now we will read about ozonolysis. So, ozonolysis has two parts. When alkenes are treated with ozone, at first they form a component called ozonides. Okay. These ozonides, when treated with zinc and water, they form fragments of smaller molecules. Okay. Now we will see how this occurs. Let's say this is one alkene and we give ozone. So, what happens at first? Ozone is like this, minus and this is plus. Because valency of oxygen is 2, this one has its 2 valency fulfilled, this one has 1, so negative charge, and this has 3, so positive charge. Now, this is the alkene. So, negative charge attacks here, pi bond breaks, it attacks this oxygen and this bond breaks and neutralizes the plus charge. So, we get this compound. This compound, okay. Now, oxygen has lone pair. This lone pair will come here. This bond breaks and this O bond breaks. So, we get CH3, CH, double bond O plus CH2, double bond O and O minus, and this will be O plus. Okay. So, now if we arrange it in a different way, we get it like this. Okay. So, this negative charge will attack on the carbonyl carbon. Since the carbonyl carbon has a partial positive charge, this bond will break and it will attack this carbon, and this bond breaks to neutralize O plus. So, we get this compound. This one is called ozonide. This is ozonide. Now, in presence of zinc and water, a cleavage occurs which forms fragments. So, we can say the cleavage as something like this. So the bond breaks like this. So in this case, look at this, each carbon which had the double bond between them, 1, 2, 3, these had the double bonds. So these carbons had the double bond in between them. So the carbons which were containing the double bond will get one oxygen each, and now they will form double bond with the oxygen, and the carbon-carbon bond has already broken. Okay. So if we cleave it like this, so this is one fragment which can be written as CH3, C double bond O and one H. Okay. This is ethanol or acetaldehyde. This is ethanol. Okay. Now if we consider this fragment, this is the second fragment. So we can say C double bond O and 2 hydrogen. This is the formaldehyde or methanol. Okay. So these are the two fragments. Now there is one shortcut to write the ozonolysis reactions. The shortcut is, let's say this is the double bond between two carbons. Okay. When we have ozonolysis and after that we are treating with zinc and water, so the trick is that cleave the double bond and add double bonded oxygen to each carbon of these double bonded carbons. Okay. So let's say if this is R1 and R2, right. So we will cleave the double bond and add double bonded oxygen to each carbon. So the first fragment is R1, CH double bond O. This is one fragment, and the second fragment is R2CH double bond O. This is the second fragment. Okay. Now let's just see one example. So if this is the reaction, what will be the products? We cleave the double bond and we add double bonded oxygen, right. So this carbon had CH3 and double bond O. So we get acetone, and here we get C double bond O H H. Okay. If we had gone through the ozonolysis step, so what will happen in the ozonolysis step? We will write the full structure without the double bond. So for ozonide formation, we have 2 oxygen on one side and 1 oxygen on one side. Okay. So this was the ozonide. Now if we had cleaven like this, then we get these two products. Okay. So this was the ozonolysis of alkenes. Now the next reaction is polymerization. Okay, so every one of us has heard of polythenes, right? We use polythene bags for carrying things, and numerous other things are made of polythene. So what is polythene? Polythene is basically polyethylene. Okay, so poly means many or multiple, and ethene, we know what is ethene. This is ethene. Okay, so when many molecules of ethene join together to form a large structure, it is called polythene. Okay, so the reaction of polymerization can be described as when small and simple molecules combine together to form large molecules of repeating units similar to the simpler molecule. Okay, so if we take a simple molecule, that is R. Okay, this one is a simple molecule. Now we have converted it to something like this and so on, continuing on both sides. Let's say n number of R's. Okay, so this is called polymer. Okay, so simpler molecules in presence of high temperature, high pressure and catalyst, the reaction is polymerization. Okay, so this reaction of combining of simpler molecules to form large molecules of repeating units in presence of high temperature, high pressure and catalyst is known as polymerization, and these large molecules are called polymers. And the small simple molecule with which we had started, this is called monomer. Okay, so alkenes show very good examples of polymerization. The first one is ethene, of course. Ethene under high temperature, high pressure and catalyst, it forms something like this, n number of times. This is polythene. Okay, now if we take we have to write here n ethene. Okay, n molecules of ethene. Now if we take n molecules of propene, so this is propene under similar conditions, high temperature, high pressure and catalyst, we form, see, the polymerization will occur with the double bonds, okay. So, this methyl group will remain intact. It happens like this. The chain elongates along the carbons having the double bonds. So, this one is polypropene. Okay. So, these are polymers. Other examples of polymers: there is PVC, there is nylon, okay. These are other examples of polymers, but these are artificial polymers. There are some natural polymers are also there, which are formed in nature. Example of natural polymers can be cellulose, chitin, rubber, etc. Okay, rubber are made artificially also, but the original rubber is the natural rubber. Okay. So, this is the polymerization reactions. Polypropenes are used for making plastic buckets, etc. Okay. So, these were the reactions of alkenes. Next, we will study about alkynes. Alkynes are the unsaturated hydrocarbons which have at least one triple bond between two carbons. Okay. So, now let us study alkynes. Alkynes, okay. So, alkynes are unsaturated hydrocarbons having at least one carbon-carbon triple bond, right. So, the number of hydrogens in alkyne is less than alkanes and alkenes, okay, because carbon has valency of 4. Now, 3 bonds are made between 2 carbons only, so only one bond is left now. So, the smallest alkyne is this. This is called ethyne, okay. Like for naming alkanes, we added ANE or N at the end. For naming alkenes, we had added ENE or IN at the end. For naming alkynes, we will add YNE or IN at the end. And the general formula for alkynes is CnH2n minus 2, since the number of hydrogens are even less than the alkenes. Alkanes were CnH2n plus 2, alkenes were CnH2n, and alkynes are CnH2n minus 2. So, we will study in details about the alkynes, about its bonding, nomenclature and everything in the next class. Thank you.